Have you ever wondered how a computer sees and understands the world around it? This question sparks curiosity, doesn't it? And it's the core of what we're discussing today, the intersection of artificial intelligence, or AI, and computer vision. So let's first understand what AI is. In the simplest terms, artificial intelligence is the pursuit of creating machines that can think, learn, and act like humans. It's a broad discipline, encompassing a variety of subfields from machine learning to natural language processing to robotics. You witness AI in action every day, from the voice assistant on your smartphone to the recommendation system of your favorite streaming service. Now, where does computer vision fit into this picture? Well, it's a specialized field of AI that focuses on giving machines the ability to see, interpret, and understand visual data. Imagine teaching a computer to understand what's in a photo, to recognize faces, or even to analyze medical images. That's what computer vision does. The intersection of AI and computer vision is like teaching a computer to have a form of human-like sight. And this is not just about mimicking the human eye. It's about equipping machines with the capability to understand context, make sense of patterns, and even predict outcomes based on visual inputs. Consider this: a self-driving car navigating through traffic. It's not just about seeing the cars, pedestrians, and traffic lights. It's about understanding what these elements mean, predicting what might happen next, and making decisions accordingly. This is where AI and computer vision intersect, creating a synergy that's leading us towards a future where machines can understand and interact with the world in ways we've never imagined before. So let's dive deeper into this fascinating world, where technology is not just about computing numbers or executing commands. It's about creating machines that can perceive and interpret the world around them, just like we do. Now, imagine a world where computers not only compute, but also see and interpret the world around them. So, what exactly is computer vision? Computer vision, in a nutshell, is a field that falls under the umbrella of artificial intelligence. It's all about teaching computers to see in a way that's similar to how humans do. But instead of eyes, computers use cameras and other sensors to capture images or video. But seeing is just the first step. What makes computer vision truly fascinating is what happens next. The computer needs to understand what it's seeing. For that, it uses complex algorithms to analyze and interpret the visual data it has captured. Think of it this way: when you look at a photograph, you can easily recognize the people in it. You can tell what they're doing, the objects they're interacting with, and even their emotions. But for a computer, an image is just a bunch of pixels. It doesn't naturally know what any of those pixels represent. That's where computer vision comes in. It uses techniques like pattern recognition, image analysis, and machine learning to help the computer understand the content of the image. This could be anything from recognizing a face, to identifying objects, to understanding a scene. For instance, a computer vision system might analyze an image of a street and be able to identify cars, pedestrians, and buildings. It could even detect if a pedestrian is about to step into the street, potentially triggering an autonomous vehicle to stop or slow down. Computer vision isn't just about understanding individual images either. It can also deal with sequences of images like video. This is even more complex because now the system needs to understand how things are moving and changing over time. But why is all this important? Well, by enabling computers to understand and interpret visual data, we can automate and enhance many tasks that currently require human vision. This has vast implications in many fields, from self-driving cars to medical imaging to surveillance and security, and beyond. In essence, computer vision is the science that aims to give a similar, if not better, capability to a machine or computer. But how does artificial intelligence play into this? Well, the marriage of artificial intelligence, or AI, with computer vision is akin to providing a brain to a pair of eyes. AI, with its advanced algorithms and machine learning models, is the powerhouse that fuels the capabilities of computer vision. Think of it this way: AI is like the puppet master pulling the strings. It instructs the computer vision system on what to do with the images it sees. AI algorithms analyze the raw pixel data from images and videos and transform it into meaningful interpretations. This process is much like how our human brain works when we see with our eyes. We don't just see shapes and colors, we recognize objects, people, and scenarios. AI brings this level of understanding to computer vision. Machine learning, a subset of AI, plays a crucial role here. Machine learning models are trained on vast quantities of data, learning to recognize patterns and make decisions based on that data. In the context of computer vision, these models are trained to recognize and categorize images. For instance, a machine learning model might be trained to recognize the difference between images of cats and dogs. Deep learning, a further subset of machine learning, takes this even further. It uses neural networks with many layers, hence the term deep, to train models. These models can recognize more complex patterns and make more accurate predictions. Importantly, the role of AI in computer vision is not static. It's a dynamic, evolving field. With advances in technology and increased availability of data, AI algorithms are becoming more and more adept at interpreting visual data. They're learning to recognize subtler patterns, make more nuanced predictions, and even learn from their mistakes. AI is the driving force that allows computer vision to go beyond just seeing. It enables understanding, interpretation, and decision-making based on visual data. It's what allows a self-driving car to navigate a busy street, a security system to identify a potential threat, or a medical imaging system to detect a disease. AI, in essence, is the brain behind the eyes of computer vision. What can we use this technology for, you may ask? Well, the applications of computer vision are as diverse as they are innovative, reaching into industries such as healthcare, autonomous vehicles, security, and more. Let's start with healthcare. Computer vision is proving to be a game changer in medical imaging. It can help detect diseases early by analyzing scans and images with a level of detail that surpasses the human eye. For instance, it's being used to detect cancerous cells in mammograms or spot signs of diabetic retinopathy in eye images. It's like having a superpowered microscope that never misses a thing. Now let's gear up and talk about autonomous vehicles. Self-driving cars are no longer a thing of the future, but a reality of our present. Computer vision is the eyes of these vehicles, enabling them to perceive and understand the world around them. It helps identify objects, gauge distances, and navigate roads, essentially making the vehicle see its surroundings. Let's not forget about security. In a world where safety is paramount, computer vision is a valuable tool. It is used in surveillance systems to identify suspicious activities or individuals, helping to keep our homes, businesses, and public spaces safer. It's even used at airports to scan luggage for prohibited items, making our travels smoother and more secure. Computer vision also has a significant role in retail, where it's used to track inventory, understand customer behavior, and even enable cashierless checkouts. It's revolutionizing the way we shop, making it more efficient and personalized. And let's not forget about agriculture. Farmers are using computer vision to monitor crop health and detect pests, which helps increase yield and maintain sustainability. It's like having an army of tireless, eagle-eyed scouts constantly patrolling the fields. In essence, computer vision is transforming our world, making it safer, more efficient, and more insightful. It's helping us see the world in a whole new light, uncovering patterns and insights that were previously hidden. The potential is truly amazing. The applications of computer vision are as vast as our imagination. Whether it's helping doctors detect diseases early, guiding self-driving cars, enhancing our security, revolutionizing retail, or boosting agricultural productivity, computer vision is opening up a world of possibilities. What does the future hold for computer vision? As we look ahead, the potential advancements and future trends in computer vision are nothing short of breathtaking. It's like standing on the edge of a new frontier, where the only limit is our imagination. Imagine this, a world where computer vision is so advanced that machines can perceive the world like a human, or even better. They can understand and interpret complex scenes, recognize patterns, and make decisions based on visual input. This isn't some far-off sci-fi fantasy, it's the future that's being shaped right now. One of the most exciting prospects is the integration of computer vision into everyday life. Imagine smart homes that recognize your face, know your preferences, and adjust accordingly. Picture a shopping experience where you walk into a store, pick up items, and walk out, with all your purchases automatically identified and billed. But the future of computer vision isn't just about convenience. It's also about safety. Think about self-driving cars that can accurately detect and react to obstacles on the road, or surveillance systems that can identify suspicious activities in real time. And let's not forget about the potential in healthcare. Computer vision could help doctors diagnose diseases earlier by identifying subtle changes in medical images that the human eye might miss. It could even assist in surgeries, providing surgeons with real-time visual data to guide their procedures. And what about the world of entertainment? Virtual reality and augmented reality are just beginning to scratch the surface of what's possible. With advanced computer vision, these experiences could become even more immersive and realistic. But perhaps the most exciting aspect is the unknown. There are applications and advancements that we haven't even thought of yet. The field of computer vision is evolving at a breakneck pace, and as it continues to grow and develop, who knows what incredible innovations we'll see. The future of computer vision is as exciting as it is vast. But what are the challenges in computer vision? Like any field in the realm of technology, computer vision is not without its hurdles. Let's dive into some of these challenges that are shaping the way we approach and refine this fascinating field. One of the most pressing issues is accuracy. Computer vision systems are trained to identify and interpret visual data, but they are not infallible. These systems can struggle with recognizing objects in different lighting conditions, unusual perspectives, or when objects are partially obscured. They can also struggle with variances in color and texture. This leads to errors and inaccuracies that can have significant consequences, particularly in critical applications such as medical imaging or autonomous vehicles. Then there is the issue of data privacy. Computer vision systems often rely on large data sets, which might include sensitive information. In an era where privacy is a paramount concern, the handling, storage, and use of such data is a complex challenge. It's a delicate balancing act between utilizing data to improve computer vision technologies and respecting individual privacy rights. Moreover, the need for vast amounts of data presents its own set of challenges. Training a computer vision system to recognize and interpret visual data accurately requires a massive amount of examples. This not only demands considerable resources for data collection and storage, but also poses challenges in ensuring the diversity and representativeness of the data. Furthermore, there is a need for robust algorithms that can handle the complexity and variability of the real world. Creating these algorithms is no easy task. It requires a deep understanding of both the technology and the specific context in which it will be used. And let's not forget the ethical concerns. How do we ensure that these technologies are used responsibly, without bias, and for the betterment of society? These questions are not just technical, but philosophical, and they require careful thought and ongoing discussion. While the potential is enormous, so are the challenges. So, where does that leave us? With a whirlwind of information about the intersection of artificial intelligence and computer vision, let's take a moment to stitch together all the pieces. Let's recap and see the bigger picture. We started our journey at the crossroads of artificial intelligence and computer vision. We discovered that these two fields are not just intersecting, but are intricately woven together. The magic happens when the analytical prowess of AI meets the perceptive capabilities of computer vision. Together, they create a powerful synergy that enables machines to understand and interpret the visual world around us. We then delved into the heart of computer vision, unraveling its essence. It's a field that empowers machines to see, interpret, and understand visual data. Be it images or video streams, computer vision uses algorithms and techniques to extract meaningful data. It's like giving eyes to AI, allowing it to perceive the world as we do. Next, we explored the pivotal role of AI in computer vision. AI is the brain behind the operation, making sense of the data gathered by computer vision. It's the intelligence that allows the machine to process, analyze, and interpret visual data, ultimately leading to informed decisions and actions. We also took a look at the myriad applications of computer vision, from autonomous vehicles and healthcare to surveillance and retail. It's a technology that's already transforming industries and our daily lives, with the promise of even more revolutionary changes on the horizon. As for the future of computer vision, it's bright and full of potential. We're on the brink of new discoveries and innovations that will further enhance the capabilities of computer vision, enabling it to understand visual data with even greater accuracy and depth. But like any other technology, computer vision is not without challenges. Issues like data privacy, algorithmic bias, and the need for vast amounts of training data are hurdles that need to be overcome. As we move forward, one thing is clear. The fusion of AI and computer vision is set to redefine the future. And that's just scratching the surface of computer vision in AI. Indeed, the world of artificial intelligence and computer vision is vast, and we've only begun to delve into its complexities and possibilities. The potential for innovation and advancement is staggering, and we're excited to see where it will lead us. If this video has piqued your interest, I encourage you to delve deeper. to explore more about this fascinating field. There are a plethora of resources available for you to broaden your knowledge. Check out online courses, read academic papers, join forums and discussions, and immerse yourself in the world of AI and computer vision. Remember, the key to understanding is curiosity and the willingness to learn. Each step you take brings you closer to uncovering the secrets of this incredible technology. Thank you for joining us on this journey into the world of AI and computer vision. Until next time, keep exploring, keep learning,